Students, welcome to our video lecture. In the last lecture, we have done all the theories of cumulative frequency distribution. Today, we are going to start the sums of cumulative frequency distribution. Now, students, exercise 2.1. We are starting with the fifth sum. First, we will start with a discrete frequency distribution. And then we will go for continuous frequency distribution. What is the sum? From the following frequency distribution, obtain less than and more than type cumulative frequency distribution. We have to obtain two types of cumulative frequency distribution, students. One is less than type and other is more than type. First of all, I am writing the given discrete frequency distribution is as below. Xi is number of errors. So here I am simply writing errors, and Fi is corresponding number of pages. So here I am simply writing pages. 0, 1, 2, 3. Corresponding frequencies are 140, 110, 120 and 30. So these are, students, you can say the given values of Xi and Fi. Now, all of you know, students, as such, there are two types of cumulative frequency distribution. First type is less than type, and second is more than type. So first of all, let us go for less than type cumulative frequency distribution. So I am giving the title less than type cumulative frequency distribution. Now, students, in less than type, all of you must pay attention. In less than type, for discrete, there are no class limits. So we have to be very careful that which columns we have to make. So in less than type, our first column will be number of errors. Number of errors less than or equal to Xi, means X. And the second column will be corresponding cumulative frequency, that is, you can say number of pages. So remember, this is like an algorithm for a discrete frequency distribution. Whenever we are preparing less than type cumulative frequency distribution, the first column will be involving the variable where we have to write less than or equal to the variable, whatever it is. It is error. So I have written number of errors less than or equal to Xi. So this is our number. Here, students, I have to write simply the values of Xi 0, 1, 2 and 3. Now, corresponding frequencies. Here, less than or equal to 0, so 140. Then for 1, add 140 and 110. So how much? 250. Then 250 plus 120. So we will have here 370 plus 30. Here we will have 400. So the total frequency, students, if I write here total frequency, then N will be how much? 400. That should come as the last CFI. Once again, students, I am explaining less than type cumulative frequency distribution. The first column in the table will be number of errors less than or equal to xi. Simply here we have to describe the variable. In second column is CFI. All of you know how to write CFI. For 0 it is 140. For 1 it is 140 plus 110, so 250. For 2 it is 140, 110 and 120 which I have added, which is 370. And for 3 it is 400. Now students, we are preparing more than type. Cumulative frequency distribution. Here also we have to make only 2 columns. And the first column we have to write number of errors. Check students, here a similar question is given on I will tell you a similar question, students, is given on page number 24. So here the first column will be number of errors greater than number of errors more than or greater than or equal to xi, that we have to write. And the second column is cumulative frequency CFI. Here again 0, 1, 2 and 3. Now students, here we have to be very careful. Let us check the frequencies already we have written. Here we end at total. And here we start with total. All the frequencies are, means the number of errors greater than or equal to 0 are all total, which are 400. So remember like this, in less than type, we end at total. In more than type, we start with total. Now subtract the frequency of 0. What is frequency of 0? 140. So 400 minus 140 will give us 260. Then again subtract the frequency of 1, which is 110. 260 minus 110. So this will give us 150. Now subtract the frequency of 2, which is 120. So 150 minus 120, that is 30. So here we end at last Fi. This we have to remember. Our last Fi is 30. Our last Fi is 30. So in less than time, we end at total. And in more than time, students, in more than time, we end at the last frequency. Once again, I have explained. Total frequency, now all the errors are greater than or equal to 0, which is 400. Now subtract the frequency of 0 from 400. 400 minus 140, 260. Then subtract the frequency of 1, which is 110. 260 minus 110, so 150. Subtract the frequency of 2, which is 120. 150 minus 120 is 30. So like this, here we have to go on subtracting from the first frequency. And in less than that, we have to go on adding from the first frequency. That you remember. Then students, this type of questions are going to be very easy. So, in the last lecture's theory, we have studied. As such, there are two types of cumulative frequency distribution. The first is less than 10 and the second is more than 10. And cumulative frequency distribution of a discrete variable is called discrete cumulative frequency distribution, and cumulative frequency distribution of a continuous variable is called continuous cumulative frequency distribution. This is an example of discrete cumulative frequency distribution. Now students, we go for the next sum, and that sum is sum number 3. One of the most interesting type of sum, students, with lengthy sum. So one has to be very careful, students, in doing this type of sums. It is with lengthy sum. First we have to prepare a distribution, and after preparing the distribution, students, we have to go for corresponding less than 10 and more than 10 cumulative frequency distribution. So exercise 2.1, students, I am reading question number 3. The data regarding number of mobile phones produced in the last 60 days by a mobile phone manufacturing company is given below. Distribute it into 10 classes. Number of classes are denoted by K. Range is denoted by R, and class length is denoted by C. Okay, we are not told to go whether to prepare an inclusive or exclusive, so we will go for inclusive. Both the ways we can do, and then obtain less than type and more than type cumulative frequency distribution from it. Okay, students, so exercise 2.1, students, we are doing sum number 3. Now the first step is to locate the highest and lowest observation. The highest observation is, students, 1075, and the lowest observation is 188. Okay, so exercise 2.1, sum number 3, I write here XH is equal to 1075 and XL is 188. So range of the data is nothing but XH minus XL. 1075 minus 188, and that range comes to 887. Now we are given that number of classes is 10. This is already given, students. Be careful. In the question only we are told that distribute the data into 10 classes. Now all of you know that C into K greater than or equal to R. So class length will be range divided by number of classes. Class length will be range divided by number of classes 887 divided by 10, so it is 88.7. Generally we keep class length in the multiples of 5 or 10. That is why I will keep class length which is nearby 88.7 is 100, so I am approximately taking class length 100. Now check this relation. C into K greater than or equal to R must be satisfied. Check. Class length is 100, number of classes are 10. This is 1000, and which is greater than the range, which is 887. So this relation, students, must be always satisfied. Our class length we have rounded off. We can take 90 also, but easy will be 100. So I have taken 100. 100 into 10, which is 1000, and 1000 is definitely greater than range, which is 887. 187. Clear, students? So, our first step, whenever students we go for frequency distribution, our first step is to locate XH and XL. Second step, find range. Third step, decide the number of classes and classlet. And the fourth step is to prepare the continuous frequency distribution, whether it is inclusive or, students, it is exclusive. So, class length, our first class must include 188 and our last class must include 1075. Our first class limits must include 188 and our last class limits must include 1075. So this was the basic. Now students, I am preparing classes by erasing this much. So all of you please pay attention, and while preparing classes we have to always give appropriate title. So it is inclusive continuous frequency distribution of production of mobile phones. So here I am writing, students, and number of classes are little bit more. So let me erase this and use the entire length and breadth of the board. Inclusive continuous frequency distribution of mobile produced in a company for last 60 days. Then we go for classes, tally marks and effort. This is the table which we have to be very careful and cautious. As I told you, our students' first class limit must include 188. So I can start from 100. So 100 to 199. This is the first class. Then 200 to 299. 300 to 399. 400 to 499, 500 to 599, 600 to 699, 700 to 799, 800 to 899, 900 to 999, 1000 to 1000, 1000 to 1099. So these are our 3, 4, 5, 6, 7, 8, 9 and 10 classes. Now students, tally marks I have already done beforehand, and I suppose you can easily do on your own. So here students, please spare me. I won't teach you how to do tally marks, that all of you know. So directly I am writing the frequencies which are 2, 4, 9, 7, 10. 2, 4, 9, 7, 10. Then 8, 9, 4, 3, 4. 8, 9, 4, 3, 4. And the total of frequency is of course 60. This total is 60. Students, tally marks I am omitting. I have already done beforehand. You can easily do on on your own. This, students, all of you have studied from standard 8. Okay. Now, students, a very important concept. Whenever we have an inclusive frequency distribution, it is compulsory to write boundary points. Because yesterday I taught you, in less than 10 cumulative frequency distribution, we use upper boundary points, and in more than 10 cumulative frequency distribution, we use lower boundary points. For exclusive, boundary points and class limits are same. For inclusive, boundary points and class limits are not same. So what you have to do, you have to make one more column here. I am not making a column here. Instead of that, I am directly using tally marks and making as my length is short. In your table, you have to extend this table and make one more column as the fourth column, and that column is of boundary points. Understood? After F1, you make one more column, that is boundary points, fourth column. Due to less space, I am erasing this. You don't erase in your table. You make the fourth column. Okay? So, after preparing distribution, if it is inclusive, we need to write boundary points. Now see the gap. Upper limit of first class is 199 and lower limit of second class is 200. Gap is 1. Yesterday in the last lecture I taught you, half the gap you subtract from lower limit to get lower boundary point. So half of gap is 1. Half the gap is 0.5. So subtract 0.5 from 100 to get lower boundary point and add 0.5 to 199. So our first boundary points will be 99.5 to 199.5. Again, subtract 0.5 from 200. So 199.5 to 299.5. Again, subtract 0.5. So 299.5. Add 0.5. So 399.5. Again, subtract 0.5. 399.5. Add 0.5. 499.5. Same 499.5 to 599.5. 599.5 to 699.5. 699.5 to 799.5. 799.5 to 899.5. 899.5 to 999.5. 999.5 to 199.5. This is the calculation of boundary points. Now we have two types of cumulative frequency distributions. First title, less than type cumulative frequency distribution. This you put in inverted commas. So here the first column will be number of mobile phones less than or equal to upper boundary point, because in less than 10, which boundary point students we use? Upper boundary point. So my first column, number of mobile less than or equal to upper boundary points. This is allowed, you can write in short. And the second column is corresponding CFI. Our second column is corresponding CFI. Clear, students? Now, it is upper boundary points. Upper boundary point starts from 199.5, but we have to start with the value always before. So I have to start with 99.5. As such, we are using upper boundary points, and all upper boundary points are starting from 199.5, 299.5, 399.5 up to 1099.5. But a custom is to start with the value before them, and the boundary point before 199.5 is 99.5. So here I have 99.5, 199.5, 299.5, 399.5, 499.5, 599.5, 699.5, 799.5, 899.5, 999.5, 1099.5. Students, this is a value before. According to definition, we have to only use upper boundary points, but a tradition is to start with the value before. And in less than type, we start with cumulative frequency 0, because there is no value less than 99.5. Now go on adding 0 plus 2. So how much? 2. 2 plus 4. 6. 6 plus 9. 15. 15 plus 7. 22. 22 plus 10. 32. 32 plus 8. 40. 40 plus 9. 49. 49 plus 4. 53 plus 3. 56 plus 4. 60. We add total frequency and we start with 0. This much you remember. There is no frequency for less than 99.5, so we have started with 0, because our first class is starting from 100. So do we have any value less than 99.5? No, so its cumulative frequency is 0. Now, more than type. More than type. Cumulative frequency distribution. Here, what we write, number of mobile phones more than or equal to which boundary points we are using? Lower boundary points. So, number of mobiles greater than or equal to lower boundary points. Second column, corresponding CFI. Now, lower boundary points are from 99.5 to 999.5 only, but as a general practice, we write a value after that. So, in short, all boundary points are covered. But technically, according to definition, we have to write lower boundary points which start from 99.5, 199.5, 299.5, 399.5, 499.5, 599.5, 699.5, 799.5, 899.5, 999.5, and 1099.5. And I told you, in more than type, we start with the total, because all frequencies are greater than or equal to 99.5. Now go on subtracting 1 value. So the second FI will be 60 minus 2, which is 58. Subtract 58 minus 4. So this is 54. 54 minus 9. So it will be 45. 45 minus 7. So it will be 38. 38 minus 10. So 28. 28 minus 8. So 20. 20 minus 9. So 11. 11 minus 4. So 7. 7 minus 3. So 4. And 4 minus 4. 0. So here we start from 0 and end at total. And here we start from total and end at 0. So, in a continuous frequency distribution, for less than 10, we use upper boundary points. For more than 10, we use lower boundary points. But technically, all boundary points are covered. So, even if you don't remember the definition and write all the boundary points from first to last, it is correct. So, this is a long sum I told you. This was our original frequency distribution, and whenever we have an inclusive frequency distribution, it is compulsory to write boundary points, and even for exclusive also we have to write boundary points. So today's lecture I am dealing with only two sums, but these two sums were a bit lengthy. Next we will do more sums of less than type and more than type. So today we conclude the lecture. Thank you, students.